So in terms of mineral production, there were roughly a dozen of these big concentrator mills that were working in the valley for a combination of different mines. And then in the concentrator mills, they needed energy, of course, for electric motors and things that were driving the big machinery. And so that was why they needed so much electricity early on. And then compressed air, a huge big two-piston compressor in here, also driven by the same turbine, and they compressed air here, piped it all the way up to the Slocan Star mine up this valley. And you can see the mine from the bridge actually there. But so the two types of energy they needed most was, compressed air for the underground workings in the mine, and mainly because they didn't have electrical technology that was safe enough or advanced enough to use underground. So they used compressed air, and then electricity mainly for the milling and the rock crushing and the processing part of it. Right. So that was why they had such a big need. Yeah. So sorry about the chaos in here. It's like I say, we kind of have everything happening.
Thanks for bringing us in off season here.
Yeah, if you come back in the summertime, all the grass is polished and it looks really good.
Oh, okay.
Yeah. It's, this being the operator's area where you could you got a panorama of the air compressing here and all of the turbine and the electrical generation here. So that's the big driver of everything under there.
Yeah.
That's the big high pressure pipe coming in right there, and there's a nozzle that comes into the bottom of the turbine. So that's the lowest point of that.
How much pressure you say is on there?
Well, we're running at 241 pounds right now. I know that because we just did the logbook. But we can vary it up to, it can be up as high as 255, just depending on what we need. So. And the big compressor was belt driven, so that leather belt was rolled up there. That's our opening around these two big motors. Piped all, went through a big condenser.
So you've never had to stop this for maintenance?
Yeah, briefly.
Oh,
but we do every 10 years we do a major inspection that it's done for most of the day. Just while we go through all the components, clean everything.
But overall, it's been running since 1897.
Yeah, and because we only have one unit, it has to run. So, whereas other power plants.
So who are you supplying right now for power?
Yeah, BC Hydro. So we feed back to Vernon, to the Montshee substation in Vernon. So we're at the end of the line here, coming all the way over from the Okanagan.
Yeah.
So the power goes through the Denver customer.
It's just another.
Well, that's Tesla's original concept, where he needed a source of DC power, specifically for the magnets and the big rotor here.
Oh, okay. So how did it get converted from DC to AC?
Well, the method was discovered after Tesla's death, and it's really a great system, which is why, so we gave that a well-deserved holiday. Now we don't have to worry about a belt and or the second unit.
Right.
So what we do is we take high voltage alternating current off of one of the phases in this big three-phase alternating current generator. We convert it to DC through a rectifier, which has no moving parts. So it just means that it's a simpler, safer, less maintenance system. And that's commonly done today, but in Tesla's time they referred to that as the exciter. So it produced the excitation current for the electromagnets in the rotor. But that's all it did. And so we do exactly the same thing now. The only thing is, it's actually generating the power it needs for its own sustenance.
Oh, wow.
So we inject some current into it from a black start. But once it picks up, then it's off and running.
So is this the same unit that got sent to the Cascade Power near Christina Lake?
It's not the same one, but it would be quite similar.
Like pretty similar.
But in the Cascade plant, they had I can't remember how many units they had, but they were maybe 3 or 4.
Oh, okay.
And so, because the Kettle River is fluctuates more
Right.
than ours does here, so
Yeah.
depending on their water flow, they could run, you know, one or all of the units. Yeah, but in this plant, just because of the geography and what they need and everything, they just figured one single big unit. They probably anticipated using it for 25 years or 30 years. They probably never expected it to be going a century.
They talked about getting that going again down in
Yeah.
Cascade in
It
the late 80s.
yeah, I was,
And then,
yeah, the building fell down,
and then,
which was really sad.
oh, is that what